We are going to look at how to solve equations that have variables on both sides of the equation. So there will be a variable on the left side of the equation, there will be a variable on the right side of the equation. And today we're going to learn how to solve those. So here's our first one: 7 times the quantity p plus 3 plus 9 equals 5 times the quantity p minus 2 minus 3p. I'm going to suggest for these, this will be pretty important to keep you from getting confused, is that you find that equal sign and draw a line, okay? Because we need to focus sometimes on just the left side and sometimes on just the right side of that equal sign. So our first step, just like it has been with multi-step equations, is to distribute. We want to go through the equation and clear our parentheses. So on the left side of the equation, I have distributive property here. So 7 times p is 7p, and 7 times 3 is 21. I'm going to copy the plus 9. I'm going to copy my equal sign. Then on the right side of the equation, 5 times p is 5p, and 5 times negative 2 is negative 10. And I will bring down the minus 3p. So step 1 is to distribute, step 2 is to combine, and you can only combine things that are on the same side of the equal sign. So I look just at the left side, this is why I drew my line. I'm going to bring down the 7p, 21 plus 9 is 30. Copy that equal sign. Then I look on the right side, I have a 5p minus 3p, that is 2p, and I bring down the minus 10. So you want to look and make sure that the left side is as simplified as it can be and the right side is as simplified as it can be. So the third step, and this is the new step, is we have to move one of these variables. I have a 7p on the left and a 2p on the right, and I need to move one to the other side of the equal sign. Well, how do I do that? So here's the main rule up here. When there's a variable on both sides of the equal sign, move the variable with the smaller coefficient. If you do this, you will end up with fewer negatives to deal with, okay? So that's just my suggestion. You can do it the other way and still get it correct, but my suggestion is to move the variable with a smaller coefficient. So I have a coefficient of 7, a coefficient of 2, that's obviously smaller. So this is a positive 2p, so I move it using inverse operations. So since that's positive 2p, I'm going to subtract 2p from both sides. 7p minus 2p is 5p. Bring down the plus 30. Bring down the equals. 2p minus 2p is 0. That's the reason I did that. I needed that to go away. And bring down this negative 10. Don't lose your minus sign. Now, at this point, you should have a 1 or 2 step equation, depending on how things worked out. Okay, so at this point, we should have no problems. I'm going to take care of this plus 30 by subtracting 30 from both sides. I end up with 5p equals negative 10 minus 30 is negative 40. I'm going to divide both sides by 5. And I get p is negative 8. Whew, look at that. That's a lot of work, but each step is very simple. Take one step at a time. Be careful and watch your signs. When you have a variable on both sides of the equal sign, some weird things can happen. Okay, so let's look at a special case. So I'm going to find my equal sign first. I'm going to draw my line. So I have negative 4 times the quantity 2x plus 1 equals negative 8x minus 2. All right, step 1, distribute. I do have some distributive property here. So negative 4 times 2x is negative 8x. Negative 4 times 1 is negative 4. So I'm going to bring down my minus 8x minus 2. Okay, so I want you to notice something here. My variables now match, right? The one on the left is negative 8x. The one on the right is negative 8x. So this is our first intuition or first hint that something's weird with this because my variables on both sides match. All right, do I have any combining to do? There's nothing to combine on the left. There's nothing to combine on the right. So I get to skip that step. Now I need to move. I need to move one of the variables. Well, I have a negative 8x and a negative 8x. They're equal. It doesn't matter which one I move. So the inverse operation to minus 8x is I'm going to add 8x to both sides. All right, so negative 8x plus 8x, that goes away. I bring down my minus 4. Negative 8x plus 8x goes away. I bring down my negative 2. My variables went away. I have no variables. And I have this statement, negative 4 equals negative 2. What? Negative 4 equals negative 2? That is never true, right? That is a statement that is never true. And I can't write very well with this pen. All right, if it's never true, that means there is nothing you can plug in for x up here and get a solution. There is no value of x that makes this true. So if it's not true, if it's never true, you write no solution. Okay, that means no value of x makes this true. But there's another weird thing that can happen when you have a variable on both sides of the equal sign. So this equation, I have negative 5 minus 9x. There's my equal sign, so I'm going to draw my line. Equals 3 times the quantity 1 minus 3x minus 8. So step 1, distributive property. So I look over here, there is no distributive property, so I'm just going to copy. Equals, I do have distributive property here. 3 times 1 is 3. 3 times negative 3x is negative 9x, and I bring down the minus 8. Okay, so I distributed. Now I look to see if I can combine. On the left, there's nothing to combine, so I'm just going to copy it. On the right, I have 3 minus 8, which is negative 5 minus 9x. Okay, notice both of these sides look exactly the same. Interesting. All right, well, let's move a variable. I have a minus 9x and a minus 9x. They're equal again, so it doesn't matter which one I move. I'm going to add 9x to both sides. And I get negative 5 equals negative 5. Well, my variables went away again, but I got something that's true, right? How often does negative 5 equal negative 5? This is always true, right? That's a statement that's always true. And if it's always true, it means that it doesn't matter what we put in for x, we will get a right answer, right? This part right here, this is always true. I don't care if I put in x equals 0 or x equals 1 or x equals negative 5,362. It will always make a true statement. And if it's always true, you get to write something that sounds really fancy. You get to say infinitely many solutions. That's a Y there. Infinitely many solutions. Okay, and yes, you need to write the whole thing. It's okay. I promise your hand's not going to fall off. So infinitely many solutions means every value of x works. Okay, so this is probably the most important part of the video. I've got 3 problems that you're going to try on your own. For each one, I want you to pause the video. I want you to work it. Then when you turn the video back on, you will see my solution and you can check if you got yours correct and you can make any corrections if you need to. So at this time, pause the video, work this problem, turn it back on when you're done. I got infinitely many solutions for this one. If you need to, pause the video and correct your work. All right, here's a second problem. Pause the video, work it, turn the video back on, and check yourself. The answer to this one is x equals 0. If you made any mistakes, you can pause the video and correct them now. Here's the last one. Pause the video, work this one on your own, then turn the video back on to check your work. When I solved this one, I got a statement that could never be true, so the answer to this one is no solution. Okay, you should be ready to go. Let's look at the next assignment in class and do our practice.